And now Kris Jusiak is going to talk us about compile time reflection.
Thank you. Firstly, I'm coming in peace, so just to point that out. So, hello, I'm Kris, and welcome to let's talk about reflection, shall we? But before we start, who is actually excited about getting reflection in C++26? Okay, most of people. Any sort of reflection? Not so much. So it has to be right. So we'll see. I shared the enthusiasm. We'll see whether you will also share it as much after the talk. But okay, so without further ado, let's begin. We'll talk briefly about the motivation, because why not? We'll dig into the reflection, and the main part of the reflection is the metaprogramming as well. There's different metaprogramming model which has been introduced with reflection. We'll talk about that. We'll take a look into the introspection and the injection part. We'll also take a look into the performance of the runtime part of the static reflection, which is kind of interesting. So, just a disclaimer, it's syntax heavy talk. So good luck keeping up. I will do my best trying to guide you through what I had to go through. But it's not that bad. It's based on the proposals, so things may change. Don't count everything will work as expected. But on the good side, everything on that on the slides compiles and has been tested. There are two currently working implementation of reflection. There is Clang, implemented by Bloomberg. Thanks, Daniel. And there is EDG. David has put effort into that one. So keep that in mind. Also, because there's a lot of underlying implementation details here, it's because we don't have the library part yet. And the talk is mainly for the library authors. I don't expect anyone who is actually like application developer being forced to deal with that, hopefully, but we'll see. So motivation, there's a lot of motivation for the reflection. Correctness, one of the main use cases I see, generating at compile time test cases out of data which you have. Safety, the more you have ability to introspect your things, the more you check. I think most of people will agree that having those capabilities will improve potential for safety and correctness. Performance, I'm coming from high frequency trading, so we care about nanoseconds, and as with any proposal, there is a potential here to squeeze a few nanoseconds now and there. So exciting. And obviously maintainability, flexibility, debuggability. That's part of it, because who likes to write stream operators for structs on their own? Anyone? There are people. We'll talk after. But there are cases for that. You can serialize, deserialize things. You can debug it easier potentially, and so on. So hopefully that kind of hook you. If not, maybe the syntax will. So let's go in. So the reflection has a few parts. There's the introspection. The introspection is like, get the enum name, get the members of the struct. That's possible with C++ 11 if you able to hack it. You can find the functions, the namespace, things like that. So that's pretty cool. The introspection part is not that interesting, in my opinion, because kind of solved, but it's good to have it. The more interesting part, in my opinion, as I pointed out, coming from biased perspective of the performance, is the code injection and the generation part. The generation part is actually not supported by the proposal yet, so sorry about that. But for example, the injection you can do. You can convert your struct array of structs to struct of arrays. You can do that with that proposal. You can pack things. We'll show that shortly. What you can't do, but we'll show example how to do it. Either way, how to generate a switch case, which is kind of handy when you know the types and you can do that at compile time. if you care about performance, you can kind of gain a lot out of that. So hopefully that sounds good. And who has implemented reflection before in some shape or form in C++ language? There are hands here just for the record. I did it many different ways, so I'll just point out some ways. Code generation with clip, clang, and CMake, one way. All of them have different trades-off. Compiler hacks, my favorite. Pretty function or source location in 20, good to go. Friend injection on top of that for metaprogramming. Compiler built-ins. So Clang 15 plus actually has built-in dump struct, which at compile time can give you the info about the struct if you want. Compilers with the reflection. Circle, it was mentioned in this conference. Who is actually seen or used Circle or no, Sean? A few people. For everyone else, go for it. It's ahead of C++, years ahead. Language support. Meta classes. So CVP front, herb, everyone probably knows. A lot of hype, maybe it will get to the CVP front. This proposal used to be kind of died down, converted into different one. Mirror, that was the type-based reflection. Very interesting, kind of started the whole reflection stuff. And that's what we will be talking mainly about here. It's the P2996, remember the number. It's not a lottery ticket winner, but it will get us somewhere. It's a reflection for C++ proposal. And if we get it, we'll get it in 26 or later. 26. Confirmed it will be 26 for better or worse. So yeah, that's the link. If you don't know WG121 link, you can find it, the whole description of the proposal, very interesting read. Advise everyone to check it. So let's begin with what is actually interesting about this proposal. It's static, meaning it's at compile time. So there's no runtime dynamic information involved out of the box, which could be, but fortunately, in my opinion, that wasn't chosen. So everything is compile time by default. You can implement the runtime part with compile time. You cannot go backwards, so better choice. And the main difference from the different proposals and kind of past of template metaprogramming in C++, it's value-based and it's const eval-based, or const expert in some cases. So that is interesting. And let's start. So basically, I will summarize the whole reflection on one slide and we'll be done. So don't go to sleep yet. So there's this new operators added with the reflection. First one is called lift, and it's with this caret character. You can also see it as ref expert in some backwards proposals. And what is that doing is actually converting this t or type or value or whatever into this reflection world. But what is really interesting is that it returns this type erased std meta info object. So it was described already, whether that's a good or not. It's not strongly type-based thing. It's actually kind of like const void star. It has zillion methods, and it's just a single thing, single type erased thing. Whether that occurs or not, we'll see. There are promises regarding that because it gives us a lot of flexibility if it comes to metaprogramming, but also it's not as good regarding the function overloading and stuff like that because you just pass type erased thing. But don't worry, C++ has a great track record with picking the right defaults, so we may be into something here. The other thing which is really interesting is the part to come back to types. It's called splicer, and it will reify the reflection word to the source code again. Like so, if you look at it from the perspective of compiler, you have this lift that will get you the meta info, a kind of AST type erased thing. And then when you're ready with that, you can go back to that that source code type, in that case expression, splice with this operator. So how many, going back a second, how many characters has been introduced so far with reflection? Let me just do it for you. 0, 1. Kind of controversial, so maybe not the best start, but there's a huge potential of that. So just to give you the example how does work, and by the way, who is using is same V to compare types, values? No one? Who is doing metaprogramming? Everyone. Okay, good audience. So you can do it with type ID, by the way, which is kind of handy because you can do that for types and values. So that's what I will be using here just to describe it. So as I pointed out before, caret lift gives you this AST type erased thing. And that's the std meta info, which has tons of methods which you can take a look into the proposal. It's not that important. It's like is complete, is a namespace, blah, blah, blah. The splice in itself, which is this operator, colon operator, has different forms. It can be for the types, for expressions, and it differs whether it's prefixed with namespace or type name. It's not that important, but to understand reflection, you kind of have to understand these two operations, which may actually even change. That might be called reflex and unreflex if someone will be mean to the proposal itself. What is interesting with that is that you can do the loop. You have a caret int, which lifting it to the meta info. Then you splice it back with the type name to type space, and you get an int. So, you did the loop, and you've been in the different meta world, and you come back. Make sense? Okay, because that's important. If you get anything out of this talk, this slide is the slide. So, who likes C++ template metaprogramming? Everyone. Who likes error messages? So yeah, there's, it's like hate and love relationship with everything I would say, because I will be talking even about stateful metaprogramming, so bear in mind that. By the way, this model which I will going to present is actually possible with C++ 17, which is kind of interesting because that's not what we have been approaching metaprogramming like. So how we do that? And as I pointed out before, all the links which are like godbolt on the top are, as my knowledge stands, compiling at the moment, although it's like they refer into the trunk head versions of the compiler, so they may change, but they were at this point of that. So snapshot of today, it's working. So everyone is using MP11 for compile-time programming, or you just write it yourself. There are some fans. So I think it's a great library, just to point it out. But how we implement add? So that's a bit different than getting recursion or tuple or magic with types. We just are in like this value-based world. So we have an array. We do this lift, ts dot dot. What is that going to return is an array of meta info. And notice here, that's the benefit of this single thing of meta info not being strongly typed, because we can have actually an array. It's not a tuple, it's an array. So that's pretty cool, right? That gives you a lot of potential here, which we'll discuss in a second. So getting env out of array, like anyone can do that, right? Index operator to n. So that will give us the meta info object of the env meta info out of this TSS ellipsis which we introduced. So what we do to go back to types? Well, we splice, right? As simple as that. Type name, because we want the type, splicer, and that's it. As simple as that. It's not actually that hard. It's not that magical. If you think about it, there's a lot of syntax, and the boilerplate is kind of, you either hate it or love it, or you just deal with it. By the way, for C++ 26, there's even better way of doing that, which is the generalized pack declaration and usage proposal which has been accepted, you can do the index into the slice. So it doesn't support slicing like Circle does, if you know that, or Python. You know Python, like you can do colon, A to B, and just get this range. You cannot do that, but you can do that. So that's really fast to compile, and you can't express it better, in my opinion. So cool stuff. So let's do a bit more with that, because I do a lot of template metaprogramming in many different ways, and I always find it either tricky to get compilation times right, or getting it to be testable. Notice that with this proposal, we are in a const expert, const eval context. We can actually write unit testing. We can TDD it. There's no issue with that because we have one single meta info object. We can put random, testing things and just go on with it. So there's no problems here. So how we approach that? Well, simple. Array is your friend. We'll do input lift with TSS. That will give us the array of this meta info. And what we can do here, notice that const expert vector is part of the C++ 20. So, and that's further on in the cycle. So we can do a simple for loop and push back to this vector, this meta info object. And what is pretty cool about that, if it comes to the compilation times, which we'll take a look about it, I will talk about it, is the fact that we can fuse operations. That's very difficult when you do metaprogramming because one, you cannot early exit. Whatever you do with like make index sequence, you cannot early exit. There's no way of doing that easily. You have to evaluate everything. With here we have for loop. You can early exit and you can fuse operations. You can do reverse and drop at the same time. And then the magic starts. So there's like these few operators which were added, exactly 2, but there's also a few meta functions which kind of helps you develop as you go. So substitute is kind of taking reflection entity and gives it back to the real world. In that case, the type list, everyone's familiar with type list, will be not instantiated, but will be substituted with the meta info vector which we produced. So we have this type list, and we have this vector of meta info objects. And then when we substitute, that will create a reflection entity which will be able to be instantiated when we do the splicing with the type list of these meta info types. That makes sense? Question?
2 questions. Do you really need the vector, or could you have used reverse and then take on the array directly?
You don't have to. The question is whether you need to do a vector. No. The only reason I use the vector is to show that we can actually do the vector for people to see that how easy that can be. That's not optimal implementation for the compilation times as well. It doesn't really matter if it's a compile time, but for the compilation time itself matters as well. So you always want to stick with the arrays because it's much faster. But yeah, you can do it in place as well. There's nothing which is actually, that's part of it's interesting. There's nothing which you cannot do in the runtime, you can do at compile time. So that's pretty cool. Okay, good question. So the further part is obviously the splicing, which is always the end. Make sense? Okay, I didn't lost you yet, I guess. So on top of that, we can actually do a bit better. Well, not compilation time-wise, but better nevertheless. So we go back to this array of meta-info objects, and with C++20 we have ranges, so we can actually do reverse and drop, right? Much nicer on the views. So it's nice, right? It's like you can do that. Whether you want to do that is actually a question whether you want to have better compilation times or whether you want to have better readability and design. So there's a trade-off here because ranges will introduce more, const evaluation required. But that's pretty cool. And what do you do further on? Substitute to the type list, and you go with the splicing. So who would like that metaprogramming model actually more than what we have right now? There are some people. Didn't convince everyone. Maybe for the good reasons, maybe not. I think it's better because you can, one, test it at runtime, meaning at compile time, as well with your fakes. So we can TDD it, you can use ranges with it, and you can do all the algorithms and knowledge you have from runtime into the compiler. So that's pretty cool. But if you go further, if you want to do filter transform, I don't want to scare you, it's more complicated. So what about the compilation times? I kind of alluded to that. So I did the deep benchmark of all the compilers and proposal and stuff like that. Just a note, it's early stages, right? We cannot guarantee, well, we cannot guarantee it will improve, but it's likely that it will improve because the implementation usually go in that direction, although it's not always the case, but there's potential here. Talking to Daniel, implementer of Clang, he said there's a lot of potential. But as it stands, it's currently like a few times slower than MP11. So not ideal at the moment, but we are getting there, and there's more room to improve that. So the introspection, maybe that's part which you all want to see when you think about the reflection. So I won't keep you without it. So here I just used the template for, which is not part of the proposal, is the expression statements, is a different proposal, not related that much, but it's nicer to express, instead of tuple apply or make index sequence, fold, blah, blah. So notice here we have new meta function as well, which is called verbosity non-static data member of. That means give me all the non-static data member of, as the name says. So that will give you, I think, a span of meta info object, which you can then, just iterate over. There's like at compile time in that case, but you can do it at, kind of runtime as well if you really want to. The problem is that you have to access the splice, which is the member splice, and that's the weird syntax. That's why it's controversial as well, because you have to do t dot and splice the member wise, right? Because you cannot, you have to get it to get the value. It makes sense. It's kind of weird syntax, but if you get used to it, that's how you would call the pointer to that function. Yeah?
I'm sure there's a reason for that, but I don't get why you need template 4, because all the objects there have the same type.
Yes, you don't need that explicitly. There's a reason why I've shown it here, but you don't need that. Okay. So the question is whether we need a template 4 to iterate over that. We don't. In that particular case, actually there's an, I'll show in a second. So that will print what you think it will print, the struct. But what you can do, if you actually do it in the cons expert kind of context with template 4, not with that proposal exactly, but you can print the value at compile time. So you can actually get the, report the cons expert value, which is EDG kind of thing. But that will be like cons expert trace at some point in some shape or form. So we can actually get the name being printed as a, kind of like a warning, print from the compiler. So that's what you have to do at the template 4 level. Make sense? So that's not that hard, right? If you have the library which will provide that, you can easily do that. So design by introspection, anyone is familiar with that? Design by introspection? Not too many people, so quickly. If cons expert requires, my favorite feature for C++ 20, popularized by Andrei Alexandrescu, you verify whether the T has the value at compile time, right? And if it has the value, you can actually go and do it. Otherwise, since that wouldn't compile, if you didn't have cons expert requires, you can do something else. So you can design and move your runtime switches like ifs to compile time. And in that case, if you have a foo which has the value member, it will go to the T value and return that. If you have a bar which doesn't have that, it will just go to 0. But notice that what is the most important part of it, it's not like hard error, because if you pass a bar and you just have if, not if cons expert requires, that just wouldn't compile because bar wouldn't have the value, right? So in that case, you have the design by introspection, and the introspection is the verifying whether you have these things. So reflection obviously builds on top of that, and you can actually implement the same thing in a different way, which is kind of interesting, not advised, but possible. So what you can do, get all the non-static data members, you get them, you use ranges, any of, right, if any is actually satisfied, you get this member and verify that the name is actually value. So that's basically is the same outcome as the previous one, but you can see the potential here. You can do way more things to introspect to get what you actually want out of that. So that's pretty cool. It gives you the same results. And I find it really interesting, and especially if you care about. Yes, question.
Hate to go back to that earlier slide, but you do actually need a template for in that example.
Yeah.
Okay.
Because the expression that does the print is not the same for every element.
Right.
The argument that is the actual predefined
Yes.
number can have different types.
Yes, that's a very good point. My apologies. I did go through with the not template for, but we actually need to do it at compile time, which has been expressed. Thank you for that. So
I am a committee member.
I understand. We can talk about standard is as well, how exactly that will be texted, but let's just move on. I appreciate that comment nevertheless. So injection. Injection is actually an interesting part in that proposal, especially. As I pointed out, we cannot generate the code, but you can inject into the classes. So if you have like unpacked, struct in that case, that takes 12 bytes. Anyone, how much size of this guy would be if you actually rearrange the members in some order? Can that be smaller than 12 bytes? Anyone? Well, 9 will be an odd number, I'd say, but closer to what it actually will be. So if you actually sort it by the size, doesn't matter whether up or down, you will get 8 bytes because of the alignment and other things. So
We have 2 ints on each chart and then 2 charts on
my apologies, but the case is the same. Sorry, the case is the same. So how you do that? Is actually quite interesting. So this thing is actually working. I made a boo-boo on the slides, but don't worry about that. That's actually a real thing. So how you would do that? So what is interesting about the fact how you do that is actually that you have the struct packed in that case, let's say, and you will inject it with the members. That's what you can do. You cannot inject types or something like that, but you can inject members into an undefined struct. So you have a struct which is templated, and you will inject into it, which is really interesting part of it. So imagine that we get all the members of the T, which has been given. We sort them by the size. And then we have this defined class, another meta function, which we can put into the packed of T with those members. And that will give us the new packed struct for that T with injected members from the unpacked thing sorted by size. So when we look into that, the size will be 8. But what is really interesting, because you can do that with C++11, but you have to do a tuple, is that you will get the names. So because you copy the names. So you can access them by the name. So that's really interesting. And the type of it will be packed. So that's kind of not that great, but nevertheless, super cool feature. So I wanted to point out about stateful metaprogramming a bit, because it's powerful, but it's a hate-love relationship, mostly hate. But nevertheless, the P996 actually supports it. And you can do a lot of things with stateful metaprogramming. You can do compile time counter, for example, and there are cases for that. You can implement borrow checker if you really want. You can do destructive move if you fancy. Type save any. So there are a lot of use cases for implementing, using the stateful metaprogramming to actually implement something with it. Whether that's advised or not, depending on the use case and other policies. But it's possible, and the proposal actually supports it. So how you would go about it? Let me just explain the weird case about the global type list, which actually changes usually people's opinions about why they really hate it. So imagine we have a main, and we'll start get type list, empty type list, global type list. That's what I'm trying to say here. Nothing happened. When we append, we'll implement that function. And in that case, the get list, the global thing, will return the type list of int, because we added the global kind of thing. Make sense so far? It's kind of not that intuitive if you're used to template metaprogramming, which is functional and immutable by default. But here, we have this stateful part of it where we inject into it. But what is more interesting, and showing that example is always kind of tricky, let's think, that's called defensive programming. What will happen to the type list with this code? Any ideas? Will it get through to this float or will not? So we have if false, if const expr false, we do assert, we throw, return false. Just don't go there, please. But no, it will actually go there. That's why you have, love-hate relationship with stateful metaprogramming, because it will be instantiated, it will be in this context, and it will be just added to the type list. So here you go. Nevertheless, it has a lot of potential, right? Because you can look at it, oh, I hate it, it's like so out of what I'm used to. But on the other hand, it gives you a lot of possibilities which usually are not possible out of the box. Does anyone like it? It's like no one. Yeah, the ODR issues. Right, there are issues which you can encounter with that. So how you would go implementing that? That's kind of interesting as well, so let's quickly take a look. So append t will be just shown in a second. Get list is simple, there's nothing really into that. So what is really interesting is there is auto equals a lambda. Anyone has an idea what that actually is forcing? Well, that will force the evaluation no matter what, because otherwise it will be memorized. And when we do get list, and depending on the compile implementation, that will be always the same. So we have to force it that go for it, find it again. So how does it work? So we have this type list kind of thing, which will be injected members to. Notice this auto at the beginning, that's for versioning. So we'll try to, because the way it works, it's not changing the same struct, right? We'll inject version 1 with those members, version 2 with other members, and stuff like that. So, going for metaprogramming, we do infinite loop, kind of not as usual. And what we are what tricks enables all of that is the is incomplete type. So we go by, incrementing it by 1. And we check whether there is type list for given value, and this reflect value which gives us the value for I in this reflection to source code. And we verify whether type list input of 0 is complete, meaning is instantiated for 1, 2, 3, 5, whatever. And if it's not, we get the members from the one which has been already instantiated and add it to this new member. And then we just define the class, which was what we've been just doing a second ago. with the substitution, meaning we'll get the type list, we reflect the value, adding new members, and what will that do? It will create a type list of 0 with like 0 members, right? Type list with 1 member. Type list of 1 with 2 members, meaning the 1 member will be from the previous type list. So you can imagine you can do a lot of magic with that, and that's stateful metaprogramming. Whether that's good or bad, I'm not here to judge. So what is also interesting about P2996 is the runtime, kind of part of it, which is only based on the examples because we don't have standard library, right? So there is no really use cases yet, just the meta functions. But let's take a look into maybe what you were looking for when I started this talk. Enum-to-string, right? Who would like that? Everyone, I guess. That's the main thing from the reflection. So this example is kind of performance bad, but it's great, so I can show how you can improve it. And the way it works is that we'll use this expansion statement again, which cannot early exit is important, right? So it will be expanded no matter what. Therefore, you have to have this local variable and put the name in there and return it. But the idea is very simple, like with everything else. You do, in that case, enumerators of enum. You go one by one. You verify whether this splice value is actually matching the value which you were given at runtime. Also works at compile time. And if it does, you just return the name of that meta info object, and then return the name. So you can imagine implementation providing that functionality. Make sense? It's kind of easy, right? It's just the for. So if you take a look into the runtime performance of it, that's obviously not great. 1, because it's using strings. 2, it's templated for, which evaluates for all the enumeration. If you have 1,000, there'll be 1,000 things, and it's just the comparison, meaning like if else, right? So we can do it differently. You can do jump table, right? That's alternative to do the enum-to-string. You can do switch case, and I don't know whether we have time, but if you have, I'll show how GCC implements switch case and the small details when it decided to change the heuristic from being jump table to being a decision tree to being a bit set to being a binary search. We had the talk today, very nice, about perfect caching, so I also show the results for that, and so on. So, as I pointed out before, P2996 doesn't allow to generate code. So you cannot generate switch case like, from the proposal. But switch case, in principle, you can generate using a trick with the nested switch, which I will show in a second. But whether that will be fully optimized, it depends on the compiler and how they will flatten the implementation. But if you ever wondered how to do the switch case if I have a type list or enum or something like that, that's the case. So let's do it. So enum-to-string, we'll go with the string view because a string is not really that valuable if you know where this enum is. We'll use deducing this because we need to call our cell recursively, and you can do that with lambda. But you can do that in before, right? You just have to pass yourself, which is kind of weird, but that's what you have to do. So we get the enumerators, we get the size, and that's how you do it. You do the switch on the value, which is given from the runtime. In the default case, you go either to the next case, or you return the unknown. Otherwise, if the enumerator is actually what you want, you just return the name of. So as simple as that, you can generate the switch case. The important part and the tricky part is that you have to do it in the default, right? So in the switch case, and the default can be anywhere, by the way, just a label. So you have a default, and you iterate recursively until you're either done or you found it when you're done. So makes sense. That's what we can do. And the performance of it depends on the compiler, whether it can flatten the nested switches which are in the default, because that will generate switch, and on the default another switch with less cases and so on. But I can assure you it actually does work in GCC, Clang, and MSBC. They both flatten that. So in that case, for example, it will generate the decision tree because we have just two simple enums. But if you have more complex case, GCC is using these clusters, so it can figure out that I have to do the jump table for that part. If they sparse enough, meaning less than 10 elements between them, that's the value there. And then you can do the bit set in GCC, not in Clang. You can do decision tree, you can do jump table, and you can do binary search. So switch case is actually much better because compiler helps us a lot, right? Can you do better? Well, you can. You can do perfect hashing, as pointed out today. It will compile, much slower in a sense, but if you need performance, you can do that, and that will be the implementation. That will be the outcome code which you will get out of it. So there'll be just 4 instruction. PXT is the BMI, which is the bit set instruction, which has 3 cycles. And we just have a few instructions, I think 6 cycles overall. And notice here we don't use the string view, because string view is kind of not great for performance if you know exactly where your data is, because you can return a buffer and get the size of it on the previous position. So you return the buffer and you know where the size is. You don't have to create a 4-byte string size thing if you're interested in the performance. So I think that's pretty cool. That gives you a very good performance, and it doesn't really matter how many enums you have and how they sparsed. It will generate the code, which is kind of optimal in that case. And this 591 is the compile time bit mask, which you have to either generate based on known values, and in case of enum, you know all of them at compile time, and in case of scoped enum, you know that you can assume that if it's safe and you don't do conversion, you can do even better, because then you know that only the values which are in the enum might be given to you. So you can do even better. So just to sum up, there is a static reflection proposal. There are a lot of goodies about it. It introduces new metaprogramming model. It has a lot of potential. It has a lot of ideas, new ideas, and we can get it in C++26. So let's go for it, in a sense. What is maybe more controversial? A bit of API thing. So this meta info, by default, has goodies and not so much. It has trade-off. The syntax, you may like it or not. You may question whether there's enough of meta functions or not, whether the meta info should have hundreds of methods and stuff like that. So you can question some things, but overall, it gives you what you need. Compilation times, as I pointed out, ranges plus conceval, that's slow. That would have to be improved, and there are ways to do it. And runtime performance, so although we have examples how to use it, that would have to be improved if it gets to the standard library. So with that, yeah, let's embrace compile time reflection, and hopefully we'll get it in 26. Thank you for that.
Thank you. Questions?
And by the way, if you're interested, what would be the different world? Look at C23 embed way of doing reflection.
Hello, thanks for the talk. And seeing the example of the switch case over an enum, would it be possible, I know that there's pattern matching already coming to the standard, but would it be possible to do some sort of pattern matching using the meta programming, static compile time reflection?
Yeah, the question is whether you could do pattern matching with compile time reflection. You could do some sort of pattern matching. You can't get, you can't generate syntax out of it, so it won't be perfect. But you can do some sort of with like lambdas and stuff like that. So won't be ideal. It won't be like the pattern matching proposal, but
No, but for the sake of it.
yeah. Well, you can do that with C++17. You can do like overloaded and lambdas and just switch kind of on types in that case, because the overload resolution will kick in.
Yeah. Thanks.
Any other question?
Hello, thanks for the talk. At our company, for example, some of the worries that sometimes are spoken is on the risk of the program being able to be decompiled and then the intellectual property stolen by the competition, let's say. If you use more reflection in your program, would you say it's easier to decompile?
Well, reflection is at compile time, so the binary wouldn't have it, right? Unless you would explicitly do it. So in that sense, that wouldn't increase it. But maybe some other ways. But by default, I wouldn't worry about it. I wouldn't think that would change because it's compile time. If it was runtime, like runtime time information based, definitely, because you would be able to get. Although it's like one thing you can get out of it, the strings will be in the binary. So if you do the like enum name, you can get the enum name in the binary. So maybe that's a concern. Yeah.
Okay, thank you.
But if you didn't use it, you would have anyway the enum names in the binary.
Yeah.
So there is no change. I mean, if I didn't use reflection and I wanted to do anything with the enums, I would end up with the enum names handwritten in the binary.
Yes, but you could obfuscate it yourself, right?
Okay, yeah.
In reflection, that would be done by you, done by the proposal. So
Understood.
I don't know. It's like I don't know.
Yeah.
It depends on the concerns. Like it's like if you're concerned about leaking information, I think you would have to obfuscate either way, right? Because like after the fact. But I don't know.
Yep. Any other question?
Yeah, thank you for the talk. And do you think is it possible to do something with string interpolation using reflection, like in Python, when you can put a variable inside curly brackets and it will input a value directly, not like stood forward or something?
To a certain degree, yeah. You can do kind of like a format where you put, like, the problem is that you would have to be able to reflect what is in your local scope, right? Give me all the names and local variables, because you can get out of the string, at compile time stream, the names which you put. So if you do braces full and you have local variable full, which you could reflect if you have that ability, which we don't, then you would be able to put it in. You would just have to, in the format itself, do the reflection of whatever scope you are in, grab the names at compile time, and then find them and put them in. So potentially yes, but that's not supported by the proposal. You cannot reflect, the current scope, what you have in current scope. So you would have to pass them in. Then yes, if you pass, if you have full and you pass full to like format, you could match it and put it, but you cannot capture it like in Python, which is cool.
Okay, thank you.
Thank you. Some other question? Okay, thank you very much.
Thank you.